Hello students. In our today's class we'll be understanding how do we determine strength of any acid or a base. To determine the strength of acid or a base, we'll need to understand the concept of pH. What do we mean by pH? pH refers to the power of hydrogen ions in a solution. You can think of pH as a scale, and this pH scale ranges from 0 to 14, where 0 being most acidic and 14 being most basic. We all know that the value of 7 on a pH scale refers to a neutral solution. As we go to values below 7, the solution becomes more and more acidic in nature. It would mean that a solution with pH 4 is more acidic than a solution with pH 6. And as we go to the values above 7, it shows an increase in the basic strength. It would mean that a solution with pH 13 will be more basic than a solution with pH 11. But now there are going to be certain questions that would come to your mind. 1. Why is this pH scale only from 0 to 14? The second very interesting question would be that H plus ions are given in a solution only by acids. So if H plus ions are given only by acids, how can we use the power of H plus ions to measure the strength of a basic solution? Because we know that we use pH to measure strength of both acids as well as bases. To get the answer to all these questions, let us look at a very interesting thing, something that is very new for you, and you will learn more of it in your next class, but a little introduction here will be helpful for you to understand the concept. We'll look at what we mean by the ionic product of water. Water has got a very interesting ability, and you call it the self-ionization ability of water. Self-ionization means that water on its own can split up into H plus and OH minus ions. It has been observed that 1 liter of pure water has 10 to the power minus 7 moles of H plus ions in it, and like the same way, it also has 10 to the power minus 7 moles of OH minus ions in it. The concentration of any ion is always represented by writing that ion in a square bracket. So if I want to represent the concentration of H plus ions, I'll put the H plus in square brackets. So as you can see here, the concentration of H plus ions is shown to you to be 10 to the power minus 7 moles per liter, means 1 liter of pure water has in it 10 to the power minus 7 moles of H plus ions. In a similar way, the concentration of OH minus ions in 1 liter of pure water is also found to be 10 to the power minus 7 moles per liter. When we find the product of the concentration of H plus into OH minus, so it is the product of the concentration of H plus ions and the concentration of OH minus ions in pure water. This product is what we call as the ionic product of water. So I hope you'll understand it and remember it now, that ionic product of water is the product of concentrations of H plus and OH minus ions in water. Since we know that the concentration of H plus ions is 10 to the power minus 7 moles and that of OH minus ions is also 10 to the power minus 7 moles, therefore the ionic product of water comes out to be 10 to the power minus 14. Now you will remember that the ionic product of water is something that always remains constant. The ionic product of water will always remain 10 to the power minus 14. Let us try to understand pH with this newly understood concept. Mathematically, how do you express pH? Again, something very new for you, and you will learn about it more in your higher classes. Mathematically, pH is defined as negative logarithm of the concentration of hydrogen ion to the base 10. I will again repeat it. Mathematically, pH is equal to negative logarithm of the concentration of hydrogen ion to the base 10. Logarithm is something that you have not yet studied, but you are going to study more about it in your higher classes. It is a mathematical operator and is going to be very useful to you in solving some complex numericals as you go in your next class. Here I'll just give you a simple rule for logarithm that will be helpful to you in your standard 10. You should always remember that the logarithm or log of any power to the base 10 is power itself. Let us make this more clear to you. Suppose if I am trying to find log of 10 raised to 3. So I am finding out the log of power 3 to the base 10. So the log of power 3 to the base 10 is going to be power itself. In a similar way, when you find out log of any power to the base 10, the log of any power to the base 10 is going to be power itself. So I can in general now say that log of 10 raised to n is going to be equal to n. Let us apply this and try to find out the pH of a solution which is neutral. So you all know that when solution is neutral, then the concentration of H plus ions in it is 10 to the power minus 7 moles per liter. So you have the concentration of H plus ions. Put this in the formula of pH. The pH of neutral solution therefore would be negative logarithm of 10 to the power minus 7, because 10 to the power minus 7 is the concentration of H plus, and that's the definition of pH, that it is the negative logarithm of the concentration of H plus ions. Since in a neutral solution, the concentration of H plus ions is 10 to the power minus 7 mole per liter, the pH of a neutral solution mathematically should be calculated as negative logarithm of 10 raised to minus 7. But log of any power to the base 10 is power itself. So the log of 10 to power minus 7 has to be minus 7. Therefore your pH has to be minus of minus 7, and that is nothing but 7. And this is how you get the pH 7 when the solution is neutral. Interesting, isn't it? Let us go ahead. Try to understand how do we find out the pH of an acidic solution. You all know what happens when we add acid to water. Nothing new, we know that acids when added to water will give out H plus ions. So, the concentration of H plus ions will now increase. We all know for a neutral solution, the concentration of H plus and OH minus ions are both 10 to the power minus 7. But as you have added an acid to water, the concentration of H plus ions has increased. But we all know that the ionic product should always be constant. So if the concentration of H plus is increasing, to keep ionic product constant, the concentration of OH minus ions has to decrease. Let us take an example to understand it more clearly. Let us say that on adding an acid, the concentration of H plus ions has increased by 10 times. So when water was neutral, the concentration was 10 to the power minus 7. But by adding an acid, I've increased it by 10 times. So now it is 10 to the power minus 7 times 10. It is increased by 10 times. So what is the new concentration now? So the new concentration of H plus ions is now 10 to the power minus 6. But in order to keep the ionic product constant, If the H plus ion has increased by 10 times, the OH minus has to decrease by 10 times. And therefore, the OH minus ion concentration now is 10 to the power minus 7 divided by 10, decreasing by 10 times, and it now becomes 10 to the power minus 8. So the H plus ion concentration, the newer one, is 10 to the power minus 6 by increasing 10 times. And the OH minus ion concentration now, by decreasing 10 times, has become 10 to the power minus 8. The ionic product still remains constant, and that is 10 to the power minus 14. But what is going to be the pH now? pH is the negative logarithm of concentration of H plus ion. And since the concentration of H plus ion is 10 to the power minus 6, pH has to be negative log of 10 to the power minus 6. But the log of any power to the base 10 is the power itself. So that is minus of minus 6, and therefore that is minus of minus 6, minus of minus 6, and therefore the pH of the solution is 6 now. What do you see? That as the H plus ion concentration increases, the pH decreases. Thus I can say that by increase in the concentration of H plus, the pH decreases. So as H plus ion concentration will keep on increasing, the pH of the solution will keep on decreasing. And this gives me a relation that pH is inversely proportional to the concentration of H plus ions. That as the H plus ions will increase, the pH will decrease. Let us take an example so that you understand it more clearly. Let us say by adding an acid, I am increasing the concentration of H plus ions by 100 times. So when the solution was neutral, the H plus ion concentration was 10 to the power minus 7. If I increased it by 100 times, the new concentration will now be 10 to the power minus 5. What will be the pH? The pH of the solution will now be negative log of 10 to the power minus 5. But the log of 10 to the power minus 5 will be minus 5, so pH is minus of minus 5, and that is equal to 5. So as I increase the concentration of H plus further, the pH decreases. Therefore, always remember that a decreasing pH is showing you an increasing concentration of H plus ions, and thus an increase in the acidic nature of the solution. You all must have very easily by now guessed what about the pH for a basic solution. What do bases do? Obviously, on adding a base, what we do is we increase the concentration of OH minus. But as we increase the concentration of OH minus, the concentration of H plus has to decrease so that we can keep ionic product constant. So if I increase the concentration of OH minus by 100 times, the new concentration of OH minus would now be 10 to the power minus 7 times 100, because neutral water has 10 to the power minus 7 moles of OH minus. I have added base and I have increased the concentration of OH minus by 100 times. So the new concentration of OH minus now is 10 to the power minus 7 times 100, that is 10 to the power minus 5. But to keep the ionic product constant, the concentration of H plus will now has to decrease by 100 times. And therefore, the new concentration of H plus now is 10 to the power minus 7 divided by 100, and that is 10 to the power minus 9 moles per liter. What will be the pH? Remember this, that pH is negative logarithm of the concentration of hydrogen ion to the base 10. And now the concentration of hydrogen ion is 10 to the power minus 9. And if the concentration is 10 to the power minus 9, pH will now be expressed as negative log of 10 to the power minus 9. But the log of 10 to the power minus 9 will be 9. and minus of minus 9 will be equal to 9. Thus, the pH of this solution, you've guessed right, is 9 now. Again, look at an interesting relation that as the concentration of H plus is decreasing, the pH is increasing. So, what is the increasing pH showing you? You have guessed it right. The increasing pH is showing you the decreasing concentration of H plus. But remember, if the concentration of H plus is decreasing, it obviously means that the concentration of OH minus is increasing, and with that, what increases is the basic nature of the solution. So I hope this video must have given you a very clear idea of why is the pH scale only from 0 to 14. It also has helped you to understand that why 7 on pH is neutral. As we go below 7, why solutions become more acidic, and as we go above 7, why solutions become more basic. That's all for today. We'll meet very soon with a new topic, a new lecture. See you all till then. Goodbye.